Hi, and welcome back to Higher Maths Functions and Graphs, Sketching Trigonometric Graphs. We're going to look at one more example. So we just looked at sketching y equals 3 sine 3x minus 60 plus 2. So I'm just going to look at sketching y equals 1 minus 4 sine bracket 3x plus 30. So to make things a lot easier and a lot clearer, it's definitely worth writing it in the form negative f of x plus 1 rather than 1 minus f of x. So negative 4 sine, and take out a common factor of 3, just as we did in question 3. So negative 4 sine 3 bracket x plus 10, close bracket, plus 1. Now again, what transformations are occurring here? Well, the negative 4 sine, the negative 4 multiplies the y-coordinate by 4. So it's essentially stretching all the y-coordinates by 4 and also reflecting them in the x-axis. The 3 here compresses all of the x-coordinates. The plus 10 moves all of the x-coordinates 10 to the left. And the plus 1 moves all of the y-coordinates up by 1. So if we continue doing it this way, it does ensure that we are likely to get the points correct. We can still make a silly mistake here and there, but we would be picking up the vast majority of available marks. So again, it's a sine curve. So 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. And then just substituting in the 0, 0, 91, etc. into this generates our 5 key points. We always want the y-intercept, guys. If we're ever sketching a graph, we really do want to know where it crosses the y-axis. We would also like to know the x-intercepts as well, but we'll cover that later on in the course. You'll find out how to do that in a couple of months' time. So I'm going to sketch these points. So we have negative 10, 1, 20, negative 3, and so on. So sketch those. I'm not sketch negative 10, 1 because that's not within 0 to 360. So there we go. But I do know that as we're dividing by 3, as we have 3x, that the period's going to be 360 divided by 3, which is 120. So this point will occur again 120 degrees later at a height of 1, so it'll be 110, 1. So I have my maximum turning point and my minimum turning point. Again, 360 divided by 3, because it's been compressed by a factor of 3, the wavelength will be 360 divided by 3, which is 120. So 80, 5, add on 120 to the x-coordinate each time. So I'll give 200, 5 and 320, 5 for the maximum turning points, and the minimum turning point as well, 20, negative 3, 140, negative 3, and 260, negative 3. Again, just by adding on 120 each time. And what else would we really like to know? Well, 360 degrees after this, the curve should return to this height. So the end of the curve should be at 360, negative 1. And that is everything.